Hello everyone and welcome to another Super Science video of the Massillon Regional Library. I'm Miss Stephanie, one of the children's librarians here, and today we're going to be doing an experiment with Newton's third law of motion. And Isaac Newton was a British scientist who lived in the 17th and 18th century. More on him a little later, but one of his most famous discoveries was the laws of motion, and we're going to focus on his third law of motion today, which is for every action or force in nature there is an equal and opposite reaction. And I thought the best way to show you this was to do a balloon rocket experiment. And for this you won't need too many things. You'll obviously need a few balloons. You'll need some type of thread because we're going to put it between two different chairs. And you can use yarn, you can use fishing line. If you have something else around your place that you want to experiment with, that's great too. You'll need some scissors to cut the yarn, some tape. Duck and masking tape both worked well for me. You'll need some straws. And this part is optional, but if you want, you could get a ruler or a tape measure to see how far your balloon rocket will go. So let's go ahead and get started. All right, so let's get started on the first part of our experiment. And what we're going to do is we're going to start by making a course for our balloon rocket to go on. And I've taken two chairs, but if you have like some sturdy objects like two tables or something, that would work too. And now let's create a path. I'm going to take the yarn. So we're going to go over here, and we're going to attach the first piece to the chair with the duct tape. Let me move so you guys can see a little better. So tear a piece off, and we're going to attach it here. And then once you attach it, just kind of pull on the yarn to make sure it's not going to come out, so it's sturdy. And then what we're going to do is we're going to take the yarn and wind it. Like, I thought this was a little easier than measuring it out, because you just take it to the other chair or table, whatever you're using. And then we're going to cut the yarn. But before we tape it to the chair, we're going to do something real quick. We're going to thread this straw through. So let me thread it through real quick. All right, let's get it down in there. We want to make sure that it's completely through. And any kind of plastic straw will work fine. I did find that the ones that didn't bend worked a little better because it was easier to thread the yarn and the fishing line through them. So let's see. Oh, here we go. And then thread it through. Make sure it's on the line. And then what we're going to do is we're going to pull it so it's tight, like this. And then let me get another piece of tape. All right, I might have to like slack it for a minute while I get this tape. There we go. So pull it tight, and then put the piece of tape over the yarn and pull on it a little to make sure it's secure. So it is. So now we're going to go back over here. I'm just going to do this, and I'm going to pull the straw all the way here. Now, we're going to tape the balloon onto the straw and let it go past. So I'm going to come over, and I'm going to go ahead and tear my piece of tape. And I'm going to make it kind of a long one. And you'll understand why once I blow up the balloon. So I'm going to put it on this because that is how the balloon is going to attach to the straw. And now we're going to blow up the balloon, like stretch it a few times. All right, and then twist it. And you may need a friend or an adult to help you with this, but you can do it by yourself. So twist it, and then you're going to hold it, and you're going to tape it to that. And once it is secure, then all you're going to do is let go, woo, and off it goes. Now, that was just a very short course. Let me show you a longer one so you get a better idea of how Newton's third law of motion works. I'm going to do a little demonstration of how Newton's third law of motion works, because for every action there is an equal and opposite reaction. And the more air that you put in the balloon, the farther we'll go. So I'm not just going to tell you that, I'm going to show you. So the first one, I'm going to blow this balloon up, not very large. It's a small little balloon. I'm going to twist it. I'm going to attach it to the straw, make sure it's secure. And it went about maybe 5, 6 feet, not too long, no, because the whole course is about 18 feet long. So let's try again. Let's try blowing the balloon up larger. So we'll take it back to the beginning. Let me get the balloon off the straw. Let me make this a much larger balloon. All right, so I'm attaching it again, making sure it's secure. And let's see if we can get it all the way to the end of the course. Ready? 1, 2, 3, go. Oh, it almost made it. It was very close, but yes, you can see it was a lot farther because the more air that you put in the balloon, the farther it's going to go because it's going to be an equal and opposite reaction. So the smaller the amount of air, the less of a reaction you get. And the more air you put in the balloon, the bigger reaction, or in this case, how far the balloon can go on the track. And there's a lot of different ways you can change up this experiment. Like you can see the different variables are things that make the experiment change, the results of it change. What you could do is you could move the chairs so it's a little more slack, the line isn't as tight, and see if that affects how far the rocket will go. You can also put it on a ramp or an incline to see if maybe gravity will slow the balloon down. And there's a couple more things you can do. Let me move into a close-up shot of some other ways you can change up this experiment. All right, as I was saying, like there's a couple other things you can do to change it up to see if that will affect about how far the balloon will go. I will use this regular size balloon for the experiment, but you can see if a long skinny balloon would change it up some. I used this size straw, but you can see if a thinner straw like this one would affect it, or you can cut your straw into a smaller piece. And then finally the type of string that you use, like I use yarn, but maybe this fishing line would make it go faster or slower, but you guys are going to have to look around your house, talk to your adult, and see if there's any other ways you can change up the experiment to see if it will affect how far the balloon will go. So have fun, and I hope all your balloons have long flights. All right, well, I hope you guys had a lot of fun doing that balloon rocket experiment, and just keep changing parts of the experiment up to see how far you can get those balloon rockets to fly. And to finish up things here, I thought I would recommend a few books. The first is, well, you may know him by his third law of motion, but really, who was Isaac Newton? And Janet Pascal wrote this fascinating biography of a fascinating man who lived from 1642 to 1727 in England. And during the 85 years of his life, Isaac Newton did a lot of interesting things and made a lot of scientific discoveries. And I'm just going to highlight just a few of them because there was a lot. First, he discovered how rainbows appear in the sky using light, and he did some experiments, other experiments with light as well. He invented the math field of calculus, which is kind of complicated, but it explains a lot of interesting things about the world. He also tried to dabble in this field called alchemy, and it's like part science, part magic, and it was just like trying to do different things like change iron into gold and like make the elixir of life, which grants immortality. And obviously that part didn't work out, but it still was a very interesting thing that he did. And something that wasn't quite related to science, but I found very interesting about his life is he actually worked for the Royal Mint of the British Empire, and this was where they made money, and Isaac Newton's job was to make fake money, and he caught several counterfeiters who were trying to make fake money. And I thought that was really interesting because you don't think of a scientist doing something like that, being a criminal investigator too. So to learn even more fascinating things about his life, check out this biography. And then for the other book I chose, this is called We Dream of Space, and this is a Newbery Honor book, and it is set in 1986, and we see the events of the Challenger shuttle rocket launch through the eyes of three siblings, Cash, Finch, and Bird. And while they live in the same house, they might as well exist in different galaxies because they have different problems in their life which are handling different ways. Like Cash is failing his classes, Finch goes to the arcade and plays pinball, and Bird is obsessed with the idea about being the first female NASA shuttle commander. And the Challenger shuttle launch, I'm not going to tell too much about this event, but this event, basically there was teachers and other astronauts went into space to do some different science experiments, and because a teacher was aboard, elementary school students watched the launch take place in live. And this launch brought them together in ways that they never thought was possible. And it's a very interesting and touching book. I liked all three siblings, but Bird was the most fun to read for me because she had like a very interesting, quirky scientific mind. Like she has lots of diagrams written in the book about different things around her house, like cassette tapes and music boxes. And it is a can be a little bit of a serious story, but there is some humor to break it up, and it is a very enjoyable read. And I learned a lot about space and rockets through this book as well. Well, thank you again for joining me for the science video. I look forward to sharing more science experiments with you soon. Have a good day. Bye.